I'm Anil Kumar sharing with you a question from my subscriber. Let me thank all the viewers and subscribers for participating actively on my channel and posting excellent questions. The question here is to evaluate trigonometric functions, rather ratios, where we are involving inverse of trigonometric ratios. So that's kind of unique. Let us see how to solve such questions, or rather evaluate such ratios. I'll begin with the very first one, which is sine of tan inverse 7/24. We'll try to understand the steps. You can then follow the same steps to evaluate the other two trigonometric ratios, correct? Now, when you say sine of tan inverse 7/24, then you could actually write this as, think like this. We have sine of something which is tan inverse 7/24. Now, what is that? That is an angle, right? That is an angle. So the inside part, which is tan inverse 7/4, we could write this as A, for example, right? So in that case, A is equal to tan inverse 7/24. Is that clear? So I could write this as equal to sine A, where A is all this, tan inverse 7/24. So I could write this now as tan A equals to 7/24, correct? Now, as soon as you get this, it is actually much simpler. You can think about now a triangle where the angle is A. Let's say this angle is A for us. I should write A, let's say ABC, okay. So this is the angle A we're talking about. Tan A 7/24 means that the opposite side is 7 and the adjacent side is 24. Does it make sense to you, right? If that is the case, what is the hypotenuse? Let's calculate the hypotenuse. Now this is a right triangle. Now in this triangle, hypotenuse should be square root of 7 square plus 24 square, right? And that is equal to 25. So this is 25 for us. Now as soon as you know this is 25, you can write what sine A is, right? So that becomes a triangle. Is it okay? In this particular triangle, we don't even have to calculate what A is. Now that is one part of looking into it. However, this question hides another very important concept, and that is, let's get back to this. Let's look into our coordinate system. Now in this coordinate system, you know that all are positive in quadrant 1, sine is positive in quadrant 2, tan is positive in quadrant 3, and cosine is positive in quadrant 4. And that simply means that when we say that tan is positive 7/24, then this triangle or angle A could be in this quadrant or in this quadrant. Do you see that? So solution lies in two quadrants. Either it is quadrant 1 or 3, correct? Based on the position of A, we really don't know where the A is from the given equation. We have two possible solutions. Do you get that? Now this is very important to understand, right? So let me repeat. So A, this triangle could be in quadrant 1 or in quadrant 3. So if it is in quadrant 1, then the value of sine A is going to be positive, right? It is opposite over hypotenuse, so it is going to be 7/25. However, If it is in quadrant 3, then the value of sine A is going to be negative 7 over 25. Does it make sense to you, right? So for part A, we have two solutions. So the answer is, if you are in quadrant 1, so we have two solutions. Quadrant 1 gives you 7 over 25, and in quadrant 3, the answer is minus 7 over 25. Is that clear? So you have to keep in mind that all these questions could have two solutions. So let me define that this term could be in any quadrant. Accordingly, we get two solutions, right? So now let's take the second one. Second one is, we need to find cosecant cot inverse of minus 4 over 3, right? So let me write this expression as equals to cosecant B, for example. Is it okay? So what we are saying is, let B be equal to cot inverse of minus 4 over 3. That means cot B is equal to minus 4 over 3. Now as soon as I say that cot B is negative 4 over 3, then I am also implying that B could be the angle in which quadrant? Now all are positive here: sine, tan and cosine. Cotangent means tan, right? Reciprocal of tan. Being negative means we're looking for something in quadrant 3 or in quadrant, let me rewrite. So we're looking for something in quadrant 2 or in quadrant 4, right? That is what we are looking for. So the angle could be in quadrant 2 or in quadrant 4. Is that clear? So that is one part. Second part is, since we are given cotangent is 4 over 3, so we can make our triangle here. Cot, let's say this is B for us this time. That's angle B is for us. 4 over 3 means adjacent side is 4 and the opposite side is 3. Now if you use Pythagorean theorem, we know the hypotenuse is going to be 5. In that scenario, if this triangle is in quadrant 2, so let's write down, if it is in quadrant 2, in that case the value for cosecant is what? Cosecant B is equal to, now cosecant is reciprocal of sine, right? So it is 5 over 3. So it gives you 5 over 3, since cosecant is positive here, right? Cosecant is positive. Here it is negative. But if you are in quadrant 4, in that case, cosecant B is equals to minus 5 over 3. Is that clear? So I hope that is absolutely clear. Now let's take up the last example, which is cos of cot inverse minus 5 over 3. So this time let me begin with the quadrant. We know all are positive in quadrant 1, sine in 2, tan in 3, cosine in 4. Since we are talking about negative value for cot, right? So cot is negative. That means we are looking for these two quadrants, right? So let me rewrite this as, let me write cos of cot inverse minus 5 over 12 as equal to cos of, let's say C, where C is equals to cot inverse minus 5 over 12. So that means cot C is minus 5 over 12. Now cot C is negative, that means we are in these two quadrants. Perfect. Now if you are in these quadrants, then The triangle which you are going to consider will have what dimensions? Cotangent is adjacent over opposite side. So this is 5 and that is 12. Since it's a right triangle, this point C is, the side here is 12 square plus 5 square square root, which is equals to 13, right? So that's a triangle. Now, if you are in quadrant 2, because this could be in quadrant 2 or in quadrant 4, cos is positive in quadrant 4, negative in quadrant 2. So we get two answers, that in quadrant 2, the value of cos C is equal to negative and cos is adjacent over hypotenuse, 5 over 13. If we are in quadrant 4, in that case, cos of C is going to be positive 5 over 13, right? So I hope that is clear. So remember, whenever you have combination of these trigonometric with their inverse, then that is how we can do it. And in 4 quadrants, you will get positive or negative value in 2 of them. So you expect 2 answers as shown here. I hope that helps. Feel free to write your comments and share your views. If you like and subscribe my videos, that'd be great. Thank you and all the best.